I'm here today with my assistant JFet the cat, and we're going to do some 3D printing for the Ducati ST4. Welcome to Hack-A-Week. Hey buddy. So some of you longtime viewers may remember JFet the cat, named after JFet transistor. I rescued him from the wheel well of a Ford Focus about 7 years ago at a garage I worked at back then. He was a tiny little kitten. He's a pretty big boy now. He loves hanging out here with me every time I do work in the office on the computer. Good buddy. So anyway, this is the program I was using, Tinkercad, to mess around with this. Let's get in a little closer. I'll show you what I got going on here. So here is the model I was working on in Tinkercad. Tinkercad is okay, kind of a quick and dirty sketching program for 3D modeling. Also does some other things. Not going to really get into the other stuff it does today, but there it is. Here's a little quickie basic of how it works. Let's grab a box, bring it over here. Let's say you want to put a hole in this box. So there's a solid box. Now over here I have various shapes, boxes, cylinders, pyramids, roofs, text, all kinds of stuff. The ones that are grayed out like this, these will create holes. So if I wanted to put a hole in this, I just simply take this cylinder, drag it over here, and let's go ahead and resize it. If I hold down the shift key, it'll resize it proportionately, and then I can raise it up a little higher. And if we take it and bring it over here to this cube, and then we group the cube together with the hole up here, we just select all, and there we go, and they're grouped together, and boom, you got a hole in there. Now if I wanted to take maybe let's just say another little section out of here, let's, for the hell of it, just grab the roof round. Now let's skip that one, let's try a different one. Let's see, we'll just grab a polygon here. Let's try that. So we got a polygon. Let's turn it into a hole. All right. If I wanted to just shear away this edge, say in this particular shape, I just put it there. Select the box and that, group them together, and voila! I have now shaved that portion away. So that's essentially how it works. Now, if I wanted to add, say, just a little piece poking out to the side here, I just grab another box, bring it over, and then I can resize it a bit, say into a little thin wall type of thing. And I could bring it up, slap it up there like that, group them together, boom, there's my new shape. Alright, so you get the basic idea. That's kind of how it works. But what if I want to go back and edit this shape? Well, it's now stuck to that. So what I'd have to do is hit Control Z a couple of times, and now I've got this thing back where it's, you know, an independent thing again. And if I wanted to raise the height of it, I could, and then go back, group it back together. There I go. Oh, but the hole's in the wrong spot. So what do I do to move the hole? Well, I have to go Control Z, Control Z, Control Z, 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 through all the steps. Oh, there we go. Now I can move the hole. See, that's the problem with Tinkercad, is once you've got your thing there, you're pretty well stuck. But it works for certain stuff, and if you really plan ahead, you can make something like this. Anyway, printed out this, and the accuracy was off by probably a good millimeter to a millimeter and a half of what it needed to be. So I can get there with all of this, but it's not that accurate. So what do we do about that? Well, I think what I'm going to do is move to SketchUp. SketchUp's a little bit better program. I've got a lot more things I can work with in here. So here's the box in Google SketchUp. I decided to do away with the little hump for the push button switch and just did a large box and dimensioned it accordingly with the window for viewing the LCD offset just a little bit. There's tons of tutorials on how to use Google SketchUp. I'm not going to get into it too deep here, But right now what I need to do is put a little hole right here for that switch. And here's the LCD, there's the little switch. And if I measure from this bottom edge to the center of the switch with my calipers, let's see, we're at about, let's just call it 57 millimeters. So I can take the tape measure tool over here and I want to measure from this inside edge. So I click there and I can let go and I can type in 5.7 down here, and that's going to make a guide for me. It should have been up on the top of that plane. Hold on. Let's try that again. Okay, so let's click there on this edge and take it up to 57 millimeters. All right, so there's the guide for that way. I need to be 13 millimeters in from this edge, and I'm just watching down here where it says 13. So there we are, 13. That's where the center of the hole needs to be. Now that I've got those guidelines in place, let's go over here to the circle tool, click in the middle, drag, and I'm going to type in 2.6. That's the radius. That's going to give me a 5.2 millimeter size hole. We'll select this. We're going to grab the push-pull tool, and I'm going to pull it down through the bottom. And let's zoom in a little closer, and you can see now we have a hole through the whole thing. Hole through the whole thing. Okay, now what we can do is export this thing out of here, and there is a extension that's export STL extension. I have that here, so there we go, export STL. We're in millimeters, and let's see, actually let me just select all when I do that. Export STL. Let's click on export, and I'm going to export it into here, and I have a previous version, so it's going to ask if I want to overwrite it. Yes, I do. And now we're going to go into Cura, and I'm going to select this and delete it. That's the former one. Let's open that file. And there it is. There's my model. So now we can save this to a SD card. I'll put this in my little SD card reader. And we're going to plug that into the computer here. There's all my files for the printer. Now I'm just going to save that to the removable drive. All the settings can be changed here. I've got it set for an infill density of 50%, which is plenty. In fact, to save a little time, I'm going to knock that down to 40%. I already tried doing a print at 50 and it looks just fine. We've got the printing temperature at 235, the build plate at 110, which worked okay. And just to save, let's go 105 on that. And what else? The build plate adhesion, I'm using a brim. That's just around the outside of the whole thing. There will be one layer that'll help hold it to the board. And I've got that set at 3 millimeters wide. And I'm going to save this to the removable drive. And we'll just hit eject. And now we can go put this on the 3D printer and let it rip. And I'm sure there's people that have done a lot more with Google SketchUp than I have. This is just barely scratching the surface of it, but you get the general idea. So we'll print this out and see how things fit. So here's the part. Zooming right along, got that whole thing worked out. You can see the small hole there. Did a couple more mods to it too before I printed it. Let's go back to the computer and I'll show you that. So looking inside here, you can see that there is a little raised section right there, that round circular spot that's raised up. Well, that's where the button goes. Okay, the button drops into that like so. So there's the button. You can see me moving it from the other side. And that button is actually a plastic button with a rubber diaphragm attached to it. And that drops into this little clear plastic piece like this, and that's what lets the button come back up. And that other round part that you saw sits on top of here and squishes against it, and that acts as a water seal. Then this little clear part goes over the top of the switch. It's a little tricky to get here by hand so you can see it, but it rests on the printed circuit board right there. Let me get it twisted around where you can see what's going on. So there's that little clear section that mounts on the printed circuit board with the black portion on it. Bear with me here, this is hard to hold all this together all at once, but I want you to see how this works. So there is okay, there's the button, there's everything right there, and when you push the button down far enough it works the switch, and that circular part is what seals the water. So what I had to do was modify, hi JFET, I had to modify my drawing and actually zoom in a bit here, and you'll see that I added this, has this raised section right here, that little ring. Hopefully I've got the dimensions right, where everything kind of squishes together and the thing drops down in there. Oh, that was a little practice making holes over there on that little thing. We can get rid of that now. So anyway, there we go. Hopefully this thing prints out okay and it's usable. And then what I'll do is just make a little cover for the back, and if everything works out okay, the printed circuit board is going to have to be kind of wedged up against here with a little piece of foam. I actually have the piece of foam that came out of it, but I'll probably just go to the hobby store and buy another piece of foam, some thin stuff to act as a cushion in there. And then I have to build a cover for the back that'll actually push against that whole thing, and then we'll figure out how to seal it up. I may just get it all together, put it in there, and super glue the damn thing together. Well, I could use ABS cement too. Okay. We're starting to get some build up now, probably up to about a millimeter and a half. It's got about 2 hours and 50 minutes to go, something like that. So we'll check back in a while. Things are looking pretty good, and since this is a prototype and I still have a few more mods to do to it, like the recess for the front little window, some provision for screws, etc. to hold it together maybe instead of the ABS glue. I'm going to go ahead and pause the print. Well, I'm going to stop the print, pull it off, and then I'm going to see how things fit in there. Go up here and hit stop print. Alright. Now we can pop this thing off the board. This ABS is pretty nice. It comes off pretty easy compared to the PLA. PLA likes to really hang on tight. And of course I'm doing this one-handed because I'm trying to hold the camera. There we go. Let's take it in and check the circuit board for fit. Okay, let's put some pieces together. See what we got. Let's try dropping the little button in. It fits a little tight, but it's okay. We can fix that real quick. This little file. So it's got a little burr in there. There we go. So the button's okay. Let's check the little clear plastic widget. That fits okay. That fits great. Wow, right over the top. Alright, now the moment of truth. We drop in the circuit board. see where everything lines up. Looks like it's going to clear the walls of everything okay. And the button works. Awesome. By the time I put some foam in there and I put in my little piece of plexiglass, not bad. That's pretty good for the first prototype. Yippee. I've got another 3D print going, another prototype after I tweaked things a bit. While that's going on, I'm out here in the shop working towards getting the headlight mounted and the fairing mounted. I've got the fairing on here just with a couple of temporary bolts. I'm going to mount the signal lights right here. I pulled a template off from the pannier carriers, the racks that I pulled the rear signal lights from, and I got the pattern of the bolts and I lined it up here where I like it and I know it'll mount okay, and then I just traced it out in relation to this bracket. Then I can take this template, go to the other side and just line it up with the bracket, and I know it'll be in the exact same place. Alright, let's just flip that over. We'll place this on here and line it all up, and then just trace out where the holes are. Now I can drill those holes out and get the signal lights mounted. Let's see, run the wire through the large hole because that's where it goes. And I've got a Allen bolt here, 6mm. Run that through there, and a 6mm nut. This is all leftover hardware from parts of the other bike. I'll just tighten this up. Finally got the headlight on. Pretty tight fit. It's actually bumping into the instruments a little bit, but meh, not so bad. And the speedometer cable, the monster one wasn't long enough. The ST cable has got a whole ton of slack here, but it's probably going to work. I guess I'll find out. It might be a little bit pulsy on the needle because of the sharp bend. There's quite a bit of a bend going on right there. You can see that bend. That's the cable, but I don't know, should work. This is a nutsert, a 7mm one to be exact. What I'm going to do is drill a hole big enough for the nutsert to go right in there in that bracket, and then I can put it in there, install it, and I'll be able to install the fairing in that bracket with a bolt, 5mm bolt, and I won't have to reach in behind and put a nut on it or anything. So this is the tool that you use. It looks a lot like a pop rivet tool. So we put the nutsert on the end. Every bolt size has a different arbor for it. So let's put this on. I screw it down, and now what's going to happen when I put this in the hole and I squeeze, it's going to expand part of this. It'll crush like this, and as it expands out, it'll anchor it into the hole. First I need to drill that hole out to the proper size. Proper size drill bit. And we just push it in and squeeze until I feel some resistance. And I know that's when it's crushed as far as it's going to crush. And then just stop there. If you go too far, you can actually do damage to the tool. And there it is. One nicely little installed nutsert, ready to receive a 5mm bolt. I'll put one on the other side now. So the fairing just drops on there like that.
get this bolt started in there. And then there's another bolt I'm going to put in right here on another little insert that I put in that I salvaged from the headlight mount. There were these rubber mounts on it, and there was a little insert that went into the rubber mount that's a 5mm thread. So it's right there. And I've got a bolt for that one too, another Allen head bolt. So let's get that one put in too. And then we'll get it all lined up. Put them in the other side and tighten it down, and I'll have the fairing installed. There it is, installed. Lovely. So now I can finish up the little box for the LCD. Still working on that. Got a prototype or two printed out. Had a little trouble on the way, but it's getting close, and it's going to mount to these two bolts here, which I'm going to redo with some longer stainless steel bolts that run down into that section down below and come up to the top, and then I'll put a little cap nut on it, make it look nice. Back to the LCD box. I finally got a good one printed out here the other day, and unfortunately my 3D printer board, control board, started messing up and it fried, which I guess is not a totally uncommon thing with that board. It's kind of a cheap board. Anyway, I ordered another one from Amazon, and it'll be here probably by Tuesday, but in the meantime I need to cut a piece of acrylic for the window for this. So I've got this little picture frame I picked up at a local hobby bric-a-brac store, and acrylic you can just cut by scoring it and then breaking it. So that's exactly what I'm going to do, is just score it with a razor knife a few times and flip it over and snap. There we go. And this should fit in there nicely. Oh, that's just a beautiful thing. There it is. It's now got a piece of acrylic in it. Now I need to glue it in there, and I picked up some new glue I'm going to try out. This stuff, Loctite G02 glue. Extra durable and versatile, crystal clear. It's not a super glue. Don't want to use super glue around acrylic because it has a tendency, as it cures, to cause some goofy frosting type things. I'm just going to try putting this on this paper first to see how much control I have. Oh, it's fairly thick stuff, so I got to be careful and not get too much in here, but also enough. So I'll just lay a little bead around the outside. Well, we'll let that cure up and see how it works out. Finally, after much redesign and planning and replanning and redesigning and reprinting and a failed 3D printer that I had to repair, finally got this thing all together. So this is the mount that's going to go on the triple clamp, and then this goes onto the back of this. I've got some foam stuff here that I'm going to use for a gasket. I just need to do one final little cut here on this notch. All put together. Let's connect it up. Make sure everything works okay, and it should. Indeed, there it is, and the little button. Yep, that works to set the clock. What time is it? It's 3:20 in the afternoon, so we could go ahead and set that right now. That looks like it'll work. Now I gotta put this in place and then push everything down at the same time. And I'm gonna put a couple of cap nuts on here at some point. For right now, I'm just throwing a couple of 8mm nylocks on there.
Nice. It's a little clunky squarish, but what the hell, you know, it's there. Can't think of much of a better way to do it. I suppose if I wanted to get really creative with the 3D printer some more, I could put these guys coming off from the side of the box and drop this down a little further, but it's functional, it works, it's there, it's done. So if you think 3D printing is easy, 1, 2, 3, 4, 5, 6, 7, 8 different versions and prototypes to get to that. So let's step back a moment and take a look at what I've done. I got those side pods on the back. I've got the single seat on there now. I switched those signal lights around. They were on the wrong side, the little drain hole. Thanks for whoever mentioned that. Somebody did. Somebody mentioned it. And there's that nifty little LCD display. Like I said, little boxy, little clunky, but maybe I can do something with it later. I was just after function right now. Form following function. Wait a minute. Yeah, I had to do that over. That was just way too obtrusive and ugly, and that's much better. It's flush now with the level of the bolts. I like that a whole lot better. And yeah, it's easy to read. Just much better looking overall. It doesn't look so much like a Volvo anymore. All right, I'm happy with that. Only took like, what, 11 tries. Also printed that on glass, which made it come out really nice. Yeah, I like this. This is good. This looks so much better than that first version I did that was sticking out too far. Okay, instruments all in place, got a fairing on, a working headlight, everything else. Still got to do that coolant reservoir bottle. I'm going to track one of those down this week, get it ordered, get that on there. Next episode, we are going to tackle the timing belts. I got the timing belts here. We're going to pop off the covers, see what these look like. Going to replace them anyway, but I'm kind of curious to see what they look like after being parked for 3 years. They're probably okay, but not going to take a chance. We're going to replace those. And going to change the oil just because it looks good, but I just want to do it so that I know what oil's in there. I'm going to put Rotella in there. The other day I got it registered, got the license plate on, everything's done there. So we're pretty close to being able to hit the road with this thing, and I have plans to head out to Charlotte the 24th, I think it is, of this month, to the Motori Italiani. It's a Italian motorcycle and car show out there, so that should be a lot of fun. And I'll definitely be getting some onboard video and some video of the bikes that are going to be there too. I'm sure there'll be lots of Ducatis, some Aprilias, maybe some Benellis, and we'll see what else shows up. All right, well, we're going to wrap it up for this episode. Thanks for watching, and until next time.